Okay, so today we are talking about vectors. A vector is a directed line segment, so it means it has a start and an end. And it has a direction and a length. So typically our vectors will start at the origin, and then it will be given in, its terminal point will be a coordinate point. The component form is written with these brackets that kind of look like arrows. This is how I know it's a vector. And vectors just preserve distance and length. So if I have 0, 0, this is telling me it's a 0 vector. And then the magnitude of a vector has like these double absolute value looking symbols. This is telling me the distance of the vector, which is found by using the distance formula. And then a vector is found by finding the change in x values and the change in y values. So for number 1, it wants me to find the component form and the magnitude of the vector. So I'm going to find it with the brackets and then give the length. The way I find my component form is I'm going to take my terminal point and subtract my initial. And I'm going to match up my x values together and then my y values together. What's this? Okay, so what I'm going to do is I am going to, what is my vector's name? V. I'm going to take the negative 1 from my terminal point, and I'm going to subtract my initial x value, which is 4, and then I have comma, and then I have 5 minus my initial y value, which was negative 7. What do you mean you're lost? I took this x value and subtracted that x value, and then this y value and subtracted this y value. Okay, so what do I get for my x value of my vector? Negative 5, and then my y value? No. 12. Okay, so this is my vector, and this is in component form. It does. You always do your terminal minus your initial. Okay. Then I need to find my magnitude, which is going to tell me the distance of this vector. So to do this, I'm going to do the square root of my x value squared, so negative 5 squared, plus 12 squared. And then I can just type that all into the calculator. Okay, so what value does this get me? So this is telling me that it's 13 units long. Questions on number 1?
What does the vector look like on the graph?
It would look like just like an arrow with a line. Because those are points. This is a line. Because it's like a ray, right? A normal equation of a line is a line that goes on forever.
Instead of it being a function that just plugs stuff in, it's literally just a line.
It's a line segment with a direction.
Okay, so it's just not a function.
Mm-hmm.
So
Okay, so two things we can do with vectors is we can do scalar multiplication and vector addition. Scalar multiplication is multiplying by a number. And then vector addition can include subtraction as well. Okay, so number 3 wants me to find 2v. What I'm going to do is I'm going to take each coordinate point in my vector and multiply by 2. So then what do I get for my x coordinate if I multiply? And that's my new vector. Okay, number 4 wants me to subtract the 2. Okay, so what I'm going to do is when I combine these, I'm going to make sure I have a minus sign in between them. So I'm going to have 3 minus negative 2 for my x value and 4 minus 5 for my y value. So what do I get for my x value? What? 5. Thought I heard someone say 10. I was like, what? 4 minus 5? And that's my vector. Okay. Number 5 is just adding the v vector times 2 times the w. So I'm going to multiply each of my coordinates in the w vector by 2. So for now I'm going to leave my v alone. For my w, what do I get? Oh, and I don't think I said it earlier, but it's important that I write these brackets so I know that I'm working with a vector and not a coordinate point. Then I want to go ahead and combine my x and y values. Okay, so I get what? So a vector is something that kind of goes like this. A coordinate point is literally just a dot on a graph. So typically, vectors are really used for like plotting airplane paths and like things that fly. Before you get started on the next three, I made a typo. This second vector should be V, not W. So I can also write vectors in a linear combination. This is basically the same thing, except my x-coordinate gets an I after it, and my y-coordinate gets a j after it. It's just not written as a point, it's written as a linear combination. So whenever a problem asks me to do this, I'm going to use the letters I and j, and they go alphabetically with x and y. So it's giving me an initial point and a terminal point, just like number 1. So I'm going to do the same thing. I'm going to take my terminal point and subtract my initial point. So I'm going to do -1 minus 2. And then instead of writing it with the vector symbols, it's going to get an I, because x's go with I. And then I'm going to do the same thing for my y values. I'm going to do 3 minus -5. And this time it gets the letter j. Okay, so what do I get for my I value? And my j value? So that's it. When it asks me to find the linear combination, I'm just writing it with i's and j's. Okay, so this last one is kind of like the bottom ones we were doing on the front side. It wants me to find a combination and put them together. So I'm going to find 2 times my u. And then I am going to subtract 3 times my v. So basically this is like substitution and combining like terms. So on my first set I want to distribute that too. 2 times -3i gets me 2 times 8j, 16j, -3 times 2i, -3 times -j, positive 3j, and then I just want to combine like terms, so I have -6i and -6i. -12i, 16j plus 3j, and then that's my final answer.